What up, Math Loose? All right. So if you're accessing this, you're doing this asynchronously. What's up? I'm just going to go through this. I'm going to go through it relatively quickly. My assumption is you've already attempted each problem to the best of your abilities. And this video is going to be for you to fill this out like a study guide. Now, this will be usable on the test, right? So the test is still, all of my tests are still going to be through MyOpenMath. That's not going to change through the end of the year. And, excuse me, what's your guys' job to do is go on to MyOpenMath. There will be questions. I would use this and your work from the Mod 6 recap to help you. So you always can leave and you have access to any help videos from prior before. So that's not an issue. Just make sure you get your stuff done, do your very best, and I will see you guys hopefully soon. This test will be open. I think I have it open till next Friday. So whatever, I believe it's open till next Friday at 11:59 p.m. is usually what it auto sets to. So just keep that in mind. Okay. All right. So with that said, let's do this. And the test does start tomorrow, not today, clearly. Okay. So here we go. Factor the following quadratics if possible. If a quadratic cannot be factored, explain why not. By the way, when I say explain why not, usually that's just, you got to show your work. So if I've got x squared minus 7 minus 5x and minus 7x squared. What are the factors of minus 7? Well, it's going to be either negative 1 and 7 or 1 and negative 7. Negative 1 plus 7 equals 6. 1 minus 7 equals negative 6. Those are my only two choices. Therefore, not factorable. So that's it. We're just showing it's not factorable. Why? Because that's the only factors here, and none of them will get me negative 5x. It's just not possible. If I could do like a 2 and a 5, but 2 times 5 is 10, so that's not going to work. Or I'm sorry, a 2 and a 7, but 2 times 7 is 14. You know, it's just not going to work. There's just no way to do it. So let's go on to the next one. 6x squared minus 15 and minus x. 6x squared times minus 15 is going to be negative 90x squared. You may be freaking out a little bit. I mean, there's lots of variables here, but really we need to get to two factors that are only one away from each other. We know one has to be negative, right? One's going to be negative, one's going to be positive. And the negative one has to be one larger than the second factor. So let's start going with factors. I've got 1 and 90, 2 and 45. Those aren't even close to each other. I've got 3 and 30. 4 doesn't go in there. 5 does go in there. 15 and 9, 18. So 5 and 18. No, getting closer. Does 6 go in there? Yeah. Oh, duh. 6 times 15. Duh. 6 and 15, but that's not going to work. 7 doesn't go in there. 8 doesn't go in there. 9 times 10. Whoa, look at that. 9 and 10 are one apart. And which one do I need to be negative? I need the bigger one to be negative, so negative 10x and 9x. And you didn't necessarily have to go through all these guys. You could have just been right off the bat and like, oh, it's 9 times 10. What? And then let's go ahead and set these up. Negative 10x and 9x. Again, order doesn't matter there. I'm going to pull out a negative 5. I can pull out 3x between 9x and 6x squared. 3 times 3x is 9x, and 2x times 3x is 6x squared. So what's my product? 2x plus 3 times 3x minus 5. Yeah, a little more challenging. You can do it. Okay, let's look down below. What does it say to do right here? It says solve for each of the following, or solve for each of the following equations for x. I should just say solve each, but there we go. Let's do this. I'm going to make a generic rectangle. A diamond, got my x squared, 8, 6x down below, 8x squared up top. That's just 2x and 4x. So let's plug it in, 4x, 2x. Do you see how I'm just flowing from one to the next? When you start getting good at these guys and putting in a lot of practice, you're just going to flow in them. And pull a 4 out, an x out. 2 times x is 2x. X times x is x squared. I'm going to have x plus 2 times x plus 4 equals 0. It said to solve for x, though, so we're not done. Now, you have a choice, guys. Listen, when it's like this, we're going to set each of these equal to 0, right? If they're just one-steppers like this, I don't care if you just say, hey, this is going to be x equals -2 and -4, right? I don't mind that at all. However, if you want to show the work, that's fine. We'd have x plus 2 equals 0, which minus 2 minus 2, x equals -2. Or x plus 4 equals 0, minus 4 minus 4, x equals -4. Either way you show it, guys, I'm fine with. All right? Okay, let's look at B. Well, this is already done for us. I literally have x minus 4 equals 0. What does this mean? That just means x minus 4 times x minus 4, but at the end of the day, it's the same thing, right? So, solve it once. Again, you either can look at it and go, that's just x equals 4, or you can do the plus 4, plus 4. I'm fine either way. X equals 4. Boom. That's it. It's a double root. And then this one right here, remember, when we don't have our c value, remember the x squared, or ax squared plus bx plus c. Whenever that's gone, I can usually just factor something out here and solve it. I can always factor out an x. So in this case, I can factor out a 3x. What am I left with? X plus 2 equals 0. Okay? Don't get tripped up. When you look at 3x equals 0, guys, don't let that trip you up. Divide both sides by 3. What's 0 thirds? 0. We can actually use the zero product property on this without even thinking about it. If I have two numbers multiplied together and they equal 0, one of them has to be 0. Since we know one of them is 3, what does that mean x has to be? 0. All right. Now let's use this x plus 2 equals 0. And again, you can minus 2 from both sides or just say x equals -2. So it's 0 and -2. Boom! You're done. All right. Now let's do this. Find the x and y intercepts for x plus 3 times 2x plus 5 without making a table or graphing. All right, let's do this. So first of all, to find the x-intercepts, I got to set each one equal to 0. X plus 3 equals 0, so I just know x is going to be -3. And 2x plus 5 equals 0. Here, let me just drag this up a little bit. So I'm going to subtract 5 from both sides. 2x equals -5. Don't trip out on this. Divide by 2. Divide by 2. X equals -5 halves. Boom. Leave it as a fraction. -2.5. I don't care. I do believe if you're doing it on My Open Math, though, it says leave as a fraction. So you would just write it as -5, put the fraction, slash, and then halves. Nothing big. Okay? So now I got to find my y-intercept, or I've got to write these as x-intercepts. Let's write it. My x-intercepts, remember, intercepts are written as coordinates. It's going to be -3, 0, and -5 halves, 0. Okay, that's my intercepts. What's my y-intercept? Well, let's write y-intercept here. What is the value of x at every y-intercept? It's 0. So how am I going to solve for this? Well, watch this. I'm going to write y equals. I'm just going to go back up to here, and I'm going to plug in 0 for x. So I'm going to have y equals 0 plus 3 in the first set of parentheses, and 2 times 0 plus 5 in the second set of parentheses. Well, 0 plus 3 is just 3, and 2 times 0 is 0, so I'm just left with 5 in the second set of parentheses. Let's multiply them together. 3 times 5 is 15. So this is 15. The other thing you could have done, if you're more comfortable with it, you could have just multiplied this out in a generic rectangle. And you would have gotten x3, 2x, and 5. What do we get? 6x, 2x squared, 5x, and 15. And then watch this. Write the sum out, 2x squared, add this together, plus 11x, plus 15. But remember, the c value is always the intercept. I'll give you another trick. You guys want it? It's really nice, really easy, works every time. it's ever written in this form, to get that C value or the Y value of the Y-intercept, just take this number, times that number. It will always work when it's in factor form. Just saying. The only thing that might affect it is if you had like a number on the outside here, you'd have to multiply that too, but there you go. All right. Those are some freebies there. Just some hints. Okay. Remember, I like to show you lots of different ways to do things, generally speaking, like at least different ways to take it, if I can, and you use the one that works best for you. Okay, our last problem here, it's our big looking one. Sketch the graph of the equation. Let me remind you about graphs, by the way, and if I ever have you sketch a graph, I'm going to look for this. Now on My Open Math, it helps you. You got to have your X and Y axis. So this is my Y, this is my X. I'm going to label the 5s. I'm actually going to label the 10 because why not? They're put off in boxes of 5, so it makes it real easy. -5, -10. I love graphs like this. -5, -10. And then let's go over here and actually do the work. Sketch the graph of the equation y equals x squared plus 2x minus 8. Be sure to identify the line of symmetry, vertex, intercepts, and the overall shape. Make sure we do this stuff. Okay? That's what we're finding. The one that gets forgot a lot is the line of symmetry. You'll see why. So, first things first. Let's go ahead and do our generic rectangle. I'm going to make it kind of small just because I want extra space, but it's up to you. So I'm going to have x squared. Here, I can actually zoom in on this little bit. X squared minus 8. 2x down here, minus 8x squared up here. Well, what am I going to do? Well, it's going to be negative 4x times 2x, because those will add to be, wait, is it a positive 2x? My bad. Positive 4x and negative 2x. That way it's positive down below. So, negative 2x here, and 4x down here. What can I pull out of here? I can pull a negative 2 out. What about x squared and 4x? X. 4 times x is 4x, and x times x is x squared. And it works, because what's 4 times negative 2? Negative 8, right? Okay. So I'm left with x plus 4 times x minus 2. Got to set it equal to 0 to use the zero product property. And what are my x's going to equal? They're going to equal negative 4 and positive 2. Now, you're welcome to set them up. You know, you can do your whole x plus 4 equals 0, subtract from both sides, x equals negative 4. You can do that. Do the same thing with x plus, or x minus 2 equals 0. Add 2 to both sides, x equals 2. But again, unless it's more than one step, you don't have to do that. That's up to you. So now I know my x-intercepts. I have negative 4, 0, and 2, 0. I can even graph those, negative 4 and 2. What's my y-intercept? Well, it's where x equals 0. Just look up here. It's always the c value, so negative 8. So I know that's right here. Look at that. Line of symmetry. Well, how do I find that x value? Well, I got to average these two. I mean, either that or you can say what number's in between them. But I'm just going to say, all right, negative 4 plus 2 all over 2. Negative 4 plus 2 is negative 2 over 2, which equals negative 1. Boom. So I know at negative 1, at x equals negative 1, I'm going to just do this little dotted line. I always do line of symmetry with a dotted line. That is the LOS. When it says to identify the line of symmetry, you need to draw it and you need to label it. Okay? That's also the x value of my vertex. And how do I finish off this process? Well, I'm going to plug it in. Y equals negative 1 squared plus 2 times negative 1 minus 8. Negative 1 squared is 1. 2 times negative 1 is minus 2 minus 8. This is minus 10. And what's 1 minus 10? It equals negative 9. So negative 9 up here. Let's go to negative 1, negative 9, right here. And remember, it mirrors itself. It always mirrors itself over the line of symmetry, so I can actually draw an extra dot. If I have this 1 away from the line of symmetry, then I can go 1 away and mirror it. Just to give me that extra point, right? And let's draw this. There we go. Boom. I've got my x-intercepts. I've got my y-intercept. You don't have to label this. I'm just reminding you. And I've got my vertex. Okay. All right. This is your study guide for the test. It's going to be awesome. There's going to be some different directions on the MyOpenMath because I'm actually going to have you do some graphing, even though it may not necessarily be on the MyOpenMath, but that'll be on your shown work portion of it. So tomorrow I'll give more directions on that. But with that said, peace out.